in Agricultural Engineering by Indian Council of Agricultural Research, New Delhi. Till today, Dr. Pradhan has published more than 90 research papers in reputed international journals and has been granted one patent to his credit. He has been the principal investigator of more than 10 research projects and supervised 6 PhD students as of now. He is a member of American Society of Agricultural and Biological Engineers and is a life member of Association of Food Scientists and Technologists India, Institute of Engineers India, and Indian Society of Agricultural Engineers. So with this brief introduction, I request Dr. Pradhan to please proceed with his deliberation. Dr. Pradhan, please.
Okay. Yeah, thank you so much, sir. First of all, I thank you, the organizing committee, the director of this program, for considering my name as a resource person, and for that I must thank you, all of you, sir, from my core of the heart. Okay, so already a brief introductions are given by sir, and thank you so much, sir, for a nice introduction. So I'm directly starting the topic. So today my title of the talk is recent advances in post-harvest processing of oilseeds. So here, so I'll be going through detail on the processing parts, the technology parts for the oilseed processing to get the maximum oil in, conventional or traditional, as well as the recent advance. Okay. So I'll be whatever the time is allotted to me, in that time I will be try to complete my lecture. Okay, so we know that the importance of the oil seed in our daily life, that is no need to highlight on that. And this oil seeds, this is the second largest crop, you can say, next to the other food grain, which is around 125 million production ton and 15 lakh ton of non-edible oil seed. And these oil seeds, they play a potential role in the employment generation in terms of at the time of farming, at the time of seed collection, at the time of oil extraction or oil separation, and other associated activity during this coming 5 years. So there is a high requirement of this technology for the employment generation also, and the higher output in oilseed crop that can help improve the Indian agricultural productivity and the farmers' income. So here, if you see the scenario of oilseed crop in India, so we know that there are many number of oilseeds are available in India, majorly the primary sources and the, you can say that the secondary sources. Part of the primary sources, they are combining some of the edible group and some of the non-edible group. If you take the edible group, like common primary sources from the oil, or you can say that the common primary oil seeds are groundnut, rapeseed, okay, like some that mustard, saron, soybean, sunflower, sesame, safflower. Okay, these are some of the example of the primary sources of the edible group. Likewise, in case of non-edible group, so castor, linseed, those are the non-edible group. Likewise, in the secondary sources, they have also in edible group, they are like seasonal crop, like cotton seed, your rice bran, your maize germ, your watermelon seed, your some of the plantation crop, coconut, your red oil palm, tree-borne oil seed like sal seed, mohua, mango kernel. Okay, all are coming under this secondary sources of the oil seed. Likewise, some of the non-edible oil seeds under the secondary sources like your neem, karanjab. Okay, so those are coming under this oil seed under the secondary sources. So almost you can see the graph, almost 72% of the total oil seeds area confined to the rain-fed farming, cultivated in the mostly marginal farmer or the, you can see the small farmer. That is because of lack of appropriate technology, or you can say that the uh, lack of appropriate technology, the cultivation under input to starvation condition, the combining the biotic and abiotic tests are some of the, you can say, the major causes for the poor productivity of the oil seeds. So taking all these condition, the, or you can say that the huge drain on the import bill, because we are importing the oil. So taking all these things, the huge drain on the import bill, coupled with the all these factor I told, like appropriate, inappropriate technology, cultivation under input. Okay, all this factor considering. So government of India, they established a technology mission oilseed, that is the TBO. So they have established a technology mission oilseed in 1986 for enhancing the domestic production of the edible oil. So, as a result of this concerted effort by this tree-borne, you can see that the technology mission oilseed production, the production of the oilseed increased from 108.3 lakh ton in 1985-86 to now it is coming around 361.009 lakh ton in 2021. Okay, so this is how the increased trend was there. So this is brought not only increase in the area, but improvement in the productivity from 570 kg per hectare in 1985-86 to 1269 kg per hectare during this in the last 2021. So during this last 2 years, like your 2019, 20, and 2020-21, our country recorded the highest oilseed production due to the effort of government of India by implementing several programs like the national mission of NFSM oilseed, TRFA oilseed, seed hub oilseed, this cluster demonstration of improved technology, your special program on the rapeseed and mustard. Okay, due to all this program, so in the last 2-3, you can say, year, our production is going high. Despite all this production, it's okay. You can say despite the impressive progress on the vegetable oil sector in the last 2 decades, the import has been rising since last 7 to 8 years. So this is the Indian condition. Still, we are importing the oil seed. Okay, so we can say as of 2021, India had nearly around 29 million of hectare of area for cultivation of the oil seed. Despite this, India remained the largest importer of the edible oil in the world. Okay, since till now, we are the largest importer, and vegetable oil is the third biggest import item after the crude oil and the gold in the country. If you compare the all import item, this vegetable oil is the third biggest item after the crude oil and after the gold in our India. And the government is extensively promoting the cultivation of oilseed to farmers and is also providing incentive to ensure this switch so that our import bill we can reduce. So government is also trying. So again, if you see the global context, India is the major producer of the oilseed, which are the second major agriculture crop in terms of tonnage and value. And for processing of the oilseed and oil-bearing material, India has a large network of oil mills employing more than 10 million people. That's why the employment generation is also high in case of this oilseed processing. So in spite of a variety of oilseed grown, like I told, various primary and secondary sources are there, other oil-bearing materials produced and a huge network of oilseed processing industry exist in the organized sector. This is what the global sector. So still in the oilseed processing sector, the problem are, according to the estimate of government of India, the country require about 24 million ton of oilseed, equivalent to 6.6 million ton of oil per year. So this is what we require. And to bridge this gap and to make India self-reliant in the vegetable oil, it has become necessary not only to augment the resource for more production of the oilseed, but also conserve the oilseed and their product by the proper processing. That is what the need of the hour. Okay. And it is reported that not less than 0.5 million ton of oil of the value, about 10,000 million rupees is lost due to the improper processing of the oil. That is what we need to talk in this lecture. Okay, so one of the important reason is that improper processing or inefficient processing of oilseeds, so that we are losing in term of value, in term of your product, in term of other condition. So some of the major constraints for this losses or this problem, or you can say this what are the problem statement I identify. So that is inefficient processing. Whatever the processing technology that we are accepting or we are doing, that is inefficient. Or you can see that we are getting less oil in. Inadequate utilization of some of the oil bearing materials such as rice bran, waste, or the thing. In that fact, whatever the waste, whatever the byproduct that we are getting from the industry, so from those byproducts, those waste, there also contain some oil that also we can utilize. But till now, that is utilization is not done as per the level. Unscientific and inadequate storage, obviously due to the unscientific or inadequate storage, there are storage losses are there. Okay, due to storage losses, finally the oil is less. Exploitation of the oilseed based protein. This is another you can see that the area where the whatever the oilseed based proteins are there, so that is not being exploited now. Inefficient and expensive packaging. Okay, another packaging, another important aspect in all the in the food processing sector, that is what also till now inexpensive, or you can say that inefficient and expensive in there. So likewise, inadequate research and development. So whatever the research and development is there, still we are doing to get the maximum oil yield. Problem in exporting oilseed materials are the big hurdle in increasing oil yield in the century, by which need attention. So till now, we are because we are importing the oil, so we need to work on the oilseed. We need to do the technology. We need to get the good oilseed material so that we can export those oilseed to the other countries. So that is what on major constraint. Okay. So taking all this consideration, so post-harvest technology that play an important role. So to minimizing the loss during maybe handling, to minimize the loss during maybe processing, or maybe at the time of preservation of oilseed and their product. That is what we need to will talk today. The traditional post-harvest processing or the recent post-harvest processing. Okay, so that is by adopting the proper post-harvest process technology. Proper post-harvest technology means efficient post-harvest technology or a state-of-art post-harvest technology. The input cost in the processing of oilseed is reduced and the oil yield is increased. That is what we require. Means we are trying to reduce the processing cost of the oilseed. At the same time, we need a higher oil recovery. So besides several value-added products that can also be produced even at rural level by introduction of the appropriate post-harvest technology. Thus, the farmers can motivated to grow more oilseed. So that if you are in the village level, in the rural level, so if you train farmer, if you demonstrate farmer, if you give the efficient technology, the proper post-harvest technology, at the farm level, they can also produce good amount of oil in, so that the farmers can motivated and they will be growing more oilseed plant. That is what motivated to the farmer. So directly now coming to the technical part of the topic. So that is the post-harvest operation that is being done to all type of mostly all type of oilseed, whatever oilseed that you are taking. So these are some of the, you can see the post-harvest operation that is being done to get the oil from the oilseed. So initial, that is the handling, your drying and storage, and the grading. These are some of the, consider the primary processing or primary unit operation that is given to all type of, you can see that the food grain, maybe including oilseed. Maybe you can take cereal, maybe you can take millets, maybe you can take pulses, okay, including this oilseed. These are the primary processing, like cleaning, grading, drying, okay. So these are the primary processing. Under secondary processing, that is the pre-treatment and the recovery oil. So number of pre-treatments methods are there, like your cleaning, dehulling, side reduction and flaking, heat treatments. Other methods are also there. We'll discuss in the later part of the slide. And also after pre-treatment, so it is the seeds are taken for the recovery of oil, or you consider the separation of the oil, or you consider the extraction of the expression of the oil through various process. some of the example I've given, maybe ghani, maybe expeller, maybe solvent extraction. So after this all means getting the oil through this technology, so then refining and banaspati production, then packaging of oil, then whatever the byproducts are there, utilization of de-oil cake meal, then marketing of oil seed. Those the last part that I'm not going to talk on those last part because it is I'm considering another on only the post-harvest processing of oil seed, maybe a traditional to recent one. Okay. So we'll discuss these post-harvest processing one by one. Okay. So I told that. So this primary processing, this handling, drying, storage, grading. Okay, all these things are common to all the food grains. So I'm starting with the pre-treatments. So this pre-treatment. So this pre-treatment I told about cleaning, your dehulling or decortication, your size reduction, and the flaking, your heat treatment. Whatever the pre-treatment is given, okay, so that is what, irrespective of any methods of oil separation, that is irrespective any oil separation means you take a oil expeller, you take a solvent extraction method, you take a ghani, or you take any method. Okay, so this pre-treatment is essential, or you can say that the certain pre-treatment of raw oil seed or certain pre-treatment of the oil seed is essential so that the more oil, the oil recovery can be increased. Okay, so that is if highest possible recovery of the quality of oil at an economical rate is to be obtained, then following pre-treatment improve the oil yield and their quality. So that's what I repeat again. So whoever working on the oil seeds or whoever working on the processing part of the oil or the oil, you can say that the extraction part or the oil expression part or the oil recovery part, okay, processing of the oil seed, then I just recommend them to go for the all this type of pre-treatment. Okay, so this you can say this pre-treatment are conventional. Okay, so traditionally all are used to increase the oil yield. Okay, so first one to it is I mean to say that increase the oil yield means you can increase the oil yield part or the amount of oil. At the same time, increase the quality of the oil also. Quality and quantity. So both will be increased with the pre-treatment process. Okay. So coming to this step, the cleaning, dehulling or decortication, size reduction, flaking, and the heat treatment. So coming to the cleaning, so they, again cleaning, that is the obviously whatever the oil seeds material that we are collecting, that you are harvesting from the field. So they may contain maybe dust, maybe leaf and other bark. Okay, many foreign material, you can say foreign materials, so undesirable material may there. So that's what the cleaning is the most important part of the oil seed and likewise other type of food grain. This oil cleaning, that is proper cleaning of oil seeds is required so that increase in the crushing capacity of the oil expeller unit, reduce the in-plant maintenance and improve the quality of the oil and the cake. If you are not cleaning properly, then what happens? So whatever the undesirable materials or the foreign materials they are present in the oil seeds, so they will be mixed, obviously mixed with the oil. In that case, the quality will deteriorate. Okay, the quality will not good as required. Again, another thing is that because these oil seeds, if you are not cleaning the oil seed properly, then those oil seeds we are taking into the oil mill or you are taking to some extraction method. In that case, there may be because of the stone, because of the other foreign material. So there is a problem in that oil expeller or in problem in that oil separation unit. Okay, so that is what in that case our maintenance, our all these things, service maintenance cost will be increased. For that to reduce all these things, the cleaning is important. Okay, that is what cleaning is done. So for the cleaning, so number of equipments are there. So I'm not going to discuss all these cleaning equipments. So number of cleaning equipments are there. Okay, you can cleaning number of way based on the size, based on the, you consider the weight, based on the gravity, based on, you consider the aerodynamic properties. Okay, lot of principles are there for the cleaning based on the cost, based on the you consider the which type of oil seed that we are doing. Based on that, we can choose the cleaning equipment. Okay, so second one, that is the most important part of the most of the oil seed. Okay, so that is the dehulling, that is the or decodification. Okay, you can see that the hull of the oil seeds, they are fibrous and have low oil content. So that's what, because those hull, or you can say that some of the you can say oil seed, that seed cover or the seed coat, they do not contain any oil. Okay, so if they do not contain any oil or the low oil, so that you need to separate out. Okay, so that's what the many oil seeds, like, and you can see. So in case of your some of the examples are given and their oil contents are given in case of kernel, in case of hull. So if that is what, suppose I'm just giving one example. Suppose you are taking groundnut and uh, you are taking the groundnut including hull, okay, including the seed coat, okay, then you will getting around 25% of oil. Whereas if you are just removing the hull and if you are only taking the kernel, that you are getting the 75%. This is how you can see from 25 to 75% oil is increasing. Okay, so that's what the decodification or the dehulling is required. Likewise, from other oil seeds are examples are given. Okay, so what about the dehulling or the decodification is there. Again, for the decodification, for the dehulling, again, number of equipments are there, decodificators are available. Okay, so their principle, again, maybe shearing and impact principles are there. So the number, like in the market or in the all, if you can Google out, there are groundnut decodificators are there, sunflower decodificators are there, your dehullers, many dehullers are there. Okay, so we can use any type of dehulling machine or decodificator to remove the or to separate the seed coat to your kernel to get the maximum oil content. So now, so coming to the size reduction and flaking, which is the another important aspect of the, you can say, your oil separation. This size reduction and the flaking, that means, as the name shows, the size reduction, we need to reduce the size. Okay, so you need to flake the oil seed so that whatever the oil globules are there, so they will be brushed there, they will be broken inside, and they will come to the surface of the. That's what this size reduction is required. So by doing the size reduction, also we are increasing the surface area so that the particle or the oil globule, they will be present inside, so they will become easy. That is the main important part of this size reduction, or the main important aspect of the principle of the size reduction. Okay, in the size reduction and the flaking, the separation of oil from the oil seed is facilitated by reduction of the seed in small particle by grinding or rolling. Or you can do any type of grinding, you can do rolling, you can do some, you can say, by other type of shearing, or you can say that the grinder machine. So you can do the size reduction as per the, again, the what size that we are taking, again, that is, again, you can say, researchable part. So okay, you can do the size, various size, and you can do the some research, and you can get maximum oil in at hard size. Okay, and the cell wall are more readily acted upon by the heat and moisture if the seed particles are small. That is what. So we are doing the small particle. That is what we are increasing the surface area, or that is what we are increasing. We are exposing all the area of the oil seed, so that whatever treatment that will be giving, heat or moisture treatment that will be giving in the next stage, so it will be readily reach there, so that so oil will come out. Hence, the size reduction of the oil seed is important for the efficient oil liquid. That is what, whenever we are doing the size reduction, better don't put whole oil seed in the process on the technology. You do the size reduction, you do the small particle size of the that oil seed. After that, you give the treatments, then you put in the oil expeller, or you put in the whatever the oil technology method that we are accepting. After the size reduction, then heat treatment is given. So that is, the cooking process coagulate the protein present in the seed, causing the coalescence of oil droplet and making the seed permeable to the flow of the oil. So that is what, if in a simple language, if you see, You can see what we are doing the size reduction, means we are just doing the particle size, or we are increasing the surface area. After that, we are doing the heat treatment. This heat treatment, you can say that we are giving some heat. We can give it, or you can, we are just cooking those oil seed. Okay, we are cooking means we are doing some heat. Once we are giving some heat to those particle, the small particle, that means the whatever the oil droplets are there. So if you just imagine, so if you are giving heat, the viscosity of the oil, there will be means the viscosity will be less. Okay, when the viscosity is less, that means that will be the flow will be easy. So that is what the principle of heat treatment, how the oil are there, so the flow will be easy to the surface. So that is what when the oil flow will be easy, then the whatever the, because seeds are permeable nature, the oil will flow out to the surface. Okay, that is the principle of the heat treatment, how it will help to increase the oil. And the process also decrease the affinity of the oil for the solid surface of the seed, because of which the best possible yield of the oil are obtained on the extraction or the expression of the cooked seed or the heat treated acid. And the heat treatment weaken the cell wall by cooking and causes the volumetric expansion of the droplet, which result in the rupture of the cell wall and explosion of the oil. That is what the principle of heat treatment, how the oil is coming out, or why the oil is coming out by giving this heat treatment. That is, once we are giving the heat treatment, we weaken the cell wall by giving the temperature, and that due to that, they causes a volumetric expansion of the droplets. Means that's what I told, the viscosity is less. That's what the volumetric expansion is more of the oil droplets, which result in the rupture of the cell wall. And once that is happened, then easily, so expulsion of the oil, or the oil is coming to the surface, and once we are giving some type of pressure, then it will be coming out. Okay, so that is what the heat treatment. So this is what this pre-treatment, size reduction and flaking, or you can say that the heat treatment is very much necessary to increase the oil yield of any type of oil. So this is one of the examples that is in our research group we have conducted. So here you can see that we have taken the various moisture level. So those are, and those who, excuse me, those who are working on the oilseed processing, so so they can do this type of research also. So like we have taken the independent variable various moisture content. We vary the moisture content from the seed 7.22 to 15%. Then those treated moisture, or those moisture sample, we are given temperature or cooked at a temperature of 50 degrees, 70 degrees, 90 degrees, 110 degree, 130 degree. Then the time of this temperature is around 5, 10, 15, 20 minutes. So these are the independent variable. The combination of with this independent variable, we check the percentage of oil recovery, residual oil. The residual oil means what is the oil percentage left in the cake, then pressing rate, and the sediment content. Okay, these are the dependent variable. With this, you can say parameter, we have seen at which condition the oil recovery will be high, or the residual oil content is less, and pressing rate, sedimentation content also we check. Okay, so this is what you can say the final result I have given here in the tabular format. Here you can see that. So the oil recovery is maximum around 73% or 73.14% exactly was obtained when the seed is conditioned to a dry basis moisture content of 9.6% level, means at this level, with a temperature at 10 degrees centigrade for 10 minutes. That is what, suppose we want to get a maximum, particularly for this seed, particularly if it's, we have conducted the research on the jatropha seed. So particularly for this seed, so if you want to get the maximum oil, then it is recommended the seed moisture should be 9.69% dry basis, and the temperature, the cook temperature, or the heating temperature, it should be 110 degrees centigrade, and the time of heating, it should be up to 10 minutes, so that we will get maximum oil recovery. That is maximum oil, that is around 73% oil we can get with this particular condition. Okay, so at this, that is what the optimum condition. With this optimum condition, oil recovery from the cooked seed was 7% higher than the uncooked seed. Suppose you take the uncooked seed, suppose at same condition, you take the uncooked seed at 9.69% moisture content, you don't give the heat treatment, then if you go for the oil separation, we use a screw-press oil expeller. So if you are extracting the oil using this expeller, then you will get 7% lower amount of oil in. So that is what, particularly for this seed, this is the optimum condition. Likewise, if you are working on some type of oil seed, then you can do similar type of research, and you can get the at what condition you will get the maximum oil recovery. Like it is a, because it is we have taken the independent variable moisture, cooking time, your cooking temperature. We can take other parameters also. Lot of parameters are there. Like I told, the particle size you can take. You can take the machine parameter. You can take other the parameters you can take to get the higher oil. Okay, so this is one example on the pre-treatment process, so that we will get the maximum oil recovery. So likewise, next part is the interesting part. So after this pre-treatment, we are going for the oil recovery. That oil recovery, the technology of the oil recovery, there are many technologies are available. Okay, these are like honey, the expeller, the solvent extraction planters, and the other technology are also there. So we'll discuss one by one how this, what are those technologies and how we can use that to get the maximum oil in. Okay, so these are some of the traditional technology, or you consider the traditional processing tech methods, so that the oil is being recovered using this method. These are the traditional method. Okay, so because based on this traditional method, or to get the higher, you can say that the oil in, this traditional method is also play an important role. So before going to the recent method, so just I want to discuss this traditional method in detail. Okay, so these are some of the traditional process, like your aqueous method, hydraulic press, your ghani, solvent extraction method, maybe the CO2 method, that is you can see that the a new method. Okay, and screw press of the mechanical expeller. Then under this, so process of the oil extraction or the oil separation process, or the in the oil processing sector, so these two terms are very much important. That is an expression and another extraction. Whenever you are using the expression term, is that is some mechanical pressing liquid out of liquid containing solid is there. That is some physical pressure to get the oil. In a layman language, you can say that we are giving some physical method, physical pressure to get the oil. That is our expression. Suppose we are giving some type of chemical or some type of solvent to separate the oil, then that is the extraction method. Okay, so these are the two important terminology, you can say that term. So that is being used in this processing of oil, that the expression of the oil and the extraction of the process. For example, here in case of your traditional process, this aqueous method, that is the extraction process. This solvent extraction process, that is the extraction process. This supercritical CO2 extraction method, that is extraction process. Whereas this hydraulic press, your ghani, your screw pressing, or the mechanical expressor, these are the expression process where we are giving some physical means to separate the oil. So we'll go one by one. So in the aqueous method, or the aqueous oil extraction method, this is very much traditional. Now nobody is using this method. So if you remember maybe your grandfather, maybe our grandmother era, so in that case, if you remember, they are just heating the oil seed in the home, and the one they are heating means first they will be, obviously they will be doing the side reduction, means that is the they will be grounded the seed, and those seeds they are taking into the boiling water, or that is heat is given, and they mixture the those you can say the mixture continuously. After some time, the oil will be floated on the surface of the water mixture. Whatever the oil is floated, those will be taken off using a spoon or something like that, and those again, those oil again heated up to evaporate the water, so that the remaining amount will be your oil. So this is the method. You can say the efficiency is very less, around 40% efficiency, 40% oil we are getting. That means another 60% we are losing. So that's what, again, this method is very tedious and time consuming and the low capacity. Because of all these factors, this method nowadays maybe nobody is using this method, or completely obsolete this method. So now another the expression method, that is what the, you can say, the physical pressure that we are giving, that is the you can say the, this should be several type of oil extraction method, that is hydraulic press. In case of hydraulic press, what happened? You can see the figure. The iron plates are there. So inside, so there is a hydraulic pump is there. Due to this hydraulic pump, so we are pressing the oil seed. Whatever the oil seeds are there, we are putting the oil seed in this iron plate. So once we are putting the, or giving the hydraulic pressure, so because of the hydraulic pressure, because of the pressing, you can see the actual photograph of the hydraulic press. So we are putting this, we are keeping the seed in this container, and we are giving the hydraulic press. Due to this pressure, the oil is oozed out, or the oil is coming out. Here again, the efficiency is around 50%. That's what another 50% oil is losing. So that's what nowadays this also this hydraulic press is nobody using because of the low oiling. So this hydraulic pressure of the seeds, so they are crossed under the hydraulic pressure of you can say 113 to 141 kg per centimeter square till the oil begin to ooze. That's what. So we are giving this pressure, hydraulic pressure of 113 to 141 kg per centimeter square, so till the oil start coming out. Okay, where the efficiency is very less, that is 50%. So now, so this ghani, you can say that the traditional honey, again the efficiency is again less, 57%. Again, that is what the loss of oils are there. Okay, so this traditionally maybe in 1970 or you can say that the 80. So this is the you can say that the machine, or this is the method of the oil separation, where the village people or the in the village level. So this ghani was very much famous to get the oil. So this another important factor, or the good factors for this ghani are that here the quality of the oil is very good as compared to the other method. Okay, the quality, the quantity may be less, the quantity, that is efficiency, may be less, but quality wise very good. Okay, so that's what, if you someone maybe asks maybe the our father or mother, our grandmother or grandfather, so they can tell about this story about this ghani, where in the 70s or 80s in the village levels, village people, they are usually get oil from the mustard, or get one of the sesame from using this type of ghani. Okay, so again, these ghanis so are improved so with the help of maybe you can see this is a traditional ghani, the same is improved standardized with the some help of some maybe in term of structure, in term of some of the rotation, in term of something other factor, other important factor, so that the capacity may be increased in the traditional ghani. So here in this ghani, the you can say that the working construction of the ghani, that is a wooden ghani of Western India, they have a capacity of 8 to 15 kg per hour, and the oil seeds are placed in the wooden pit. You can just visualize here. Here the wooden pit is there, so you can put the oil seed here. Again, the load beam is weighted down with either heavy stone or the even the seated operator. Okay, so here you can see. So this is the load beam. Just you can just imagine a mortar and pestle that we are using in our home. Okay, the same principle, exactly same principle apply here. Okay, so we are here, it is the load bin. Here you can see some stone, the operator is, the human power is seated here to give some load so that the crossing will be occur. Okay, so it is rotating continuously. It is rotating continuously with a continuous rotation. So the seat first, it will do the side reduction, it will break. After that, it will continue, it will give some pressure. Okay, so and the oil will coming out in the below part. So that is what it is written. As the animal move in a circular orbit, the pedestal rotates, exerting the lateral pressure on the pit, and then first pulverizing the oil seed, that is the side reduction done, then the crossing out of the for the separating the oil. Okay, after pulverizing, after side reduction, it will again and again it will rotate. Because of that, the pressure develop and the oil will come in. The oil is collected at the base of the pit. Okay, so this is the base of the pit where the oil is collected. So this is how the ghani work, where the efficiency is less. Okay, so again, so if you or recently you have seen the TV advertisement, and this again is nowadays slowly coming with help of the motor operated ghani. So all this I have shown is the human power or the animal operated ghani. Okay, nowadays this motor operated ghanis are coming. Okay, so in spite of this, you can say that the load, in spite of this animal, in spite of this human being. Okay, so thus it is fabricated with a motor, with the help of the motor. So again, the wood pit, the wood part is the similar part. Maybe that is converted into stainless steel, and that is converted with the help of your motor, that is electrical operator or motor operated ghani. I just forgot to give a photograph. I have photo, I have video of those type of ghani also. Okay, again, if you seen the advertise of Baba Ramdev, the cold pressing, the ghani press oil, nowadays very famous. Okay, the cold press oil, the ghani press oil of Baba Ramdev, Patanjali oil, that is very much famous nowadays. Because I told that, initially I told that, although the quantity is less, the efficiency is less, the quality is very good. So that's what, because nowadays we are much more concerned about the health. Even if the more money, we are going toward the more the good quality of the food. So that's what. So the ghani is now again replacing, again coming into the picture, like with Baba Ramdev, so much advertisement, and lot of private company are also coming to means fabricate their motor operated ghani, so that they will be get a good quality of the oil with the help of this ghani. Okay, so this is for the ghani. So now again another method. So that is the solvent extraction method. Here it is the extraction method, because we are using the chemical here. So many type of chemical are used. Mainly the N-hexane, that is mostly used to separate the oil, to extract the oil. Here in case of, you can see the efficiency is around 99%, 99%. That is 100% efficiency. Okay, that means whatever the oil content in the oil seeds are there, so you can get 100% oil in case of this solvent extraction process. Okay, so that is what mainly for the research purpose, or to know the oil content of any unknown seed, then it is recommended you go for the solvent extraction process, so that you can get the 100% oil. To know the oil, if you want, if you have a unknown seed, many 3-1 oil seeds are there. If you know, if you want to measure the oil content of that particular seed, you go for the solvent extraction, you can know the particular seed. But this process, again, time consuming, again, the cost is very high, and the maintenance is also a problem, and a skill, maybe skills person can only handle this type of equipment. Okay, this is some of the limitation. Okay, so the same thing is written here. Here, the thing is that again, so if you are separating the oil seed with the help of the solvent extraction process, because of the cost, because of the other cost associated with this technology, so the production cost of the per liter cost will be higher. Again, because of we are using N-hexane or some of the solvent, those maybe present in that oil. Okay, or otherwise you can say that the removal of those chemical is not possible 100%. Okay, so that is which is maybe health hazard. Or maybe you can say the otherwise you can say the quality of the oil is degrade. Okay, so that is for the some limitation. But in the research purpose, if you want to know the oil content of any oil seeds, you can go for this solvent extraction method. Okay, so I'm just skipping this written part. Okay, so now again coming to the another expression method which is most common. Okay, throughout the world, anywhere in the India, anywhere in the world, if you go, you can get this mechanical expeller. Okay, so this mechanical expeller that is most popular oil separation method from the vegetable oil seeds in the world. Because this mechanical expeller, this is simple and sturdy in construction, easily maintained. This can be operated by semi-skilled supervisor, or you can say most of the oil seed we can use or you can adopt quickly for processing of different type of kinds of oil seed. You can say at all type of oil seed we can take here using by mechanical oil expeller, and you can extract the oil. You can separate the oil using this mechanical expeller. That is what the most popular throughout the world. So this mechanical oil expeller, so you can get the cold pressing oil or the wet pressing oil. So in the cold pressing, there is no thermal treatment before or during the operation. There is no thermal treatment, which if you remember some slide before, I told that we need to do the side reduction, we need to do the heat treatment, cooking, all these things. Okay, so if you are not doing anything, then you are directly taking the oil, okay, then that is the cold pressing oil. And if you are doing some type of moisture conditioning with a maybe some other type of, you can see that the heat treatment, other type of thing, then that is the wet pressing oil. Okay, so here, so because the moisture content and the free fatty acid, they are the most important factor of the any oil, and the maximum oil can be achieved after the two to three number of pressing in case of this oil expeller, and which is consume more energy. So we'll also consider all these factors whenever we are getting the oil expeller. So you can see the actual photograph of a screw press oil expeller having capacity of 30 kg per hour, where the efficiency is 73 to 85%. Or you can see that based on the oil seed, based on the method, based on the pre-treatment method, based on which method you are following for the oil separation, based on that, this efficiency will vary 73 to 80%. That means maximum 85% of oil we can get achieved through this type of oil expeller. Again, another type, you can see, so this is the line diagram of the oil expeller. We'll discuss here later part, okay, including all the component of the oil expeller. Okay, you can see here it is the actual photograph of this oil expeller. So because we have this oil expeller and we have just you can say dismantle this oil expeller with the major component. This is for this barrel. This is for the screw, the most important component of the oil expeller, the expeller screw. Based on the screw design, based on the design of the screw, your oil content or the oil yield will vary. So these are some of the, you can say, the cage bar, where they make a round shape inside this caging, and what about by joining this, and what about the space in between that, so oil will coming out, or oil will be flow out through this spacing. You can see this is the cage. Okay, cage bar. These are the cage bar, and oil will be coming out once we are putting the oil seeds. So okay, so because this is a choke is there, the pressure develop, the temperature develop. Because of that, the oil is coming out through this expeller. So there are a number of oil expellers units are available in the country. So likewise, this you can say that the extruder type screw press oil expeller, mainly the common name is screw press oil expeller. Here the common name is 4-bolt oil expeller. Okay, here you can see the number of bolt. You can count the number of bolt. 1, 2, 3, 4. That's what is the 4-bolt oil expeller. The principle, the working principle is similar to this oil expeller, or you can say that for all oil expeller, the working principle is same. That is, we are putting the oil seed in the hopper. Once we are putting the oil seed through the help of this screw mechanism, so it will convey the oil seed from the you can say feed end to your discharge end. Okay, so that is the crushing end. Okay, so due to the screw rotation, so the oil, they will be start conveying from one end to another end, or to feed end to your you can say discharge end. Once it will going through, in between that, in the first section is the feed section, in the second section their crossing section, or the side reduction of the, you can see that the oil seed will be occur. When the side reduction occur, then it will again go forward, where the in the crossing zone, so they will be crossed, and because it is choked in air, they will be choked here. Because of that, because continuous movement is there, because rotation is there, because of that the pressure develop, also the temperature develop. Because of that, because of the high pressure, so the oil is coming out. So this is again because of all these things, the temperature is there, though, so that by default we are giving the side reduction. In the same time, we are giving the heat treatment. We are same time we are giving the, you can add some moisture here, so that to add some to get the maximum oil in. Okay, all this pre-treatment also is done here to get the maximum oil. For all the oil expeller, so the principle is same here. Okay, so only thing is the design is different. Based on the design, based on the capacity, so various type of oil expellers are available. Like it is 4-bolt oil expeller. Based on the number of bolt, it is named as 4-bolt oil expeller. Obviously, if you compare the 6-bolt oil expeller, the capacity is high in case of 6-bolt oil expeller as compared to the 4-bolt oil expeller. So you can see, you can count the number of bolt: 1, 2, 3, 4, 5, 6. Okay, that's the 6-bolt oil expeller, where capacity is more as compared to the 4-bolt oil expeller. Okay, again, the principle and other things are same. So likewise, this is a Dorman design oil expeller where the efficiency is high, around 80 to 85%. Here again, the principle is same. We are putting the oil seed, they are coming here with the help of the screw. But design, the screw design, you can, and their you can say cage bar design is somewhat they are changed, so that to get the maximum pressure, and once they are getting maximum pressure, means that's where get the maximum oil in. So that is what some, if you compare to this oil expeller or the Indian type oil expeller, slightly the efficiency is higher in case of Dorman design oil expeller. Then, whatever the oil expellers that I have shown you, again, there are two important principles are there. They involve the two important principles that I told: the disintegration and the pressing. In the first step, the oil globules are separated. That's what I told. The side reduction, the heat treatment is done. In the second step, the pressing is done. Okay, that is what the top membrane, they are surrounding the oil droplet, is exposed and brushed under the high pressure. And by doing that, the oil is coming out to the outside. This is what the principle of any type of oil expeller. Okay, again, the component of oil expeller, just these are some of the theoretical part of the oil expeller, the screw configuration. Okay, so if someone want to design an expeller, or someone want to work more on the oil expeller part, so that will be helpful for all this theoretical part, where this, I told, this feed section, ram section, and the plug section, where in this feed section we are putting the oil seed. In the ram section, the side reduction is occur. In the plug section, the pressure develop where the oil is coming out. This is what the figure of a screw. Likewise, different zones you can divide. So like a feeding zone, transport zone, compression zone, extrusion zone, and the expansion zone. Again, the same thing. Again, here, again, a small part is there. In the feeding zone, we are feeding the sample. In the transport zone, so due to the rotation of the screw, it will transport the oil seed forward or to the discharge end, or to the expansion end. In the compression, the seed are crushed, means the side reduction occur. In the extrusion zone, where the high pressure occur, due to the high pressure, you can see the oil is coming out, and the cakes are coming out in the expansion zone. That's what, whatever the cakes, they are coming out here as a byproduct, and the main product as the oil we are getting from the below the oil expeller. This is what you can describe the zone of the screw press. Okay, so now whatever I discussed based on the mechanical expeller, this is a complete flow chart for the if you want to follow or you can follow a process, you can follow this complete flow chart to get the oil. Okay, again, obviously, based on the which type of oil seed that you are using, which type of method you are using, what type of process you are using, what is the moisture content, what is the heat treatment, what is the RPM, what is size reduction, based on all these factors, so the oil yield will vary. Okay, this is generalized, you can say that the flow chart to get the maximum oil content. Okay, so now, okay, so I'll be completing soon with some of the recent advances in the oilseed processing. So now I think till this slide, so we got an idea what are the various method of oil separation, how the oil separation is done, what is the pre-treatment is done, how to get the maximum oil recovery. Okay, so now in the recent advances in the oil processing, so these are some of the recent advances or recently people are using, or some of the research and development still going on this type of processing technology, that is the supercritical CO2 extraction, tabletop extruder type oil expeller, enzyme assisted oil extraction, ultrasound assisted oil extraction, microwave assisted oil extraction, pulse electric field assisted oil extraction. You can say that all this technology or recent advance, that what I am saying, these technology, so they will be single-handedly, they cannot be used, but they can be combinedly, they can be used. Like suppose you take an ultrasound assisted oil extraction, you take the pre-treatment as the ultrasound, you take pre-treatment as the pulse electric field, you take the pre-treatment as the microwave, you treat the pre-treatment as the enzyme. After pre-treatment, after giving the pre-treatment, again you come to the technology. Again, you can use the help of your maybe solvent extraction, maybe your oil expeller. Then you will get the maximum oil content. This is for the you can say broadly, overally, you can for your knowledge. So I'll briefly I'll describe all the, you can see that the technology. What is that? This supercritical CO2 extraction technology, or that is what the green technology. This is an alternative method for extraction of the oil for the natural compound. Here, in this SeCO2 method, this allows supercritical carbon dioxide at a temperature near the room temperature and relatively low pressure. And the low critical temperature of the carbon dioxide, that is 31 degrees centigrade, that allows the extraction of thermolayable compound without degradation and the solvent residue. That is what if you are giving the high temperature, maybe whatever the thermolayable temperature components are there, they may be degraded. But here, because of the low critical temperature of the carbon dioxide, so whatever the thermolayable compounds are there in the oilseed, they can also not degrade, or without degradation, we can get those compounds. Here, the oil obtained by the supercritical CO2 extraction are of outstanding quality. The yield are comparable with those by the organic solvent method. That is why the yield, you can say the efficiency of this SeCO2 method is around, you can say around 95%. In fact, this CO2, whatever the extracts are there, they are generally recognized as safe. That is what I told you, the green method. So therefore, this supercritical CO2 may be served as a very promising technology in the food processing and the pharmaceutical processing for the extraction of the not only the oil, other component also. So this is the supercritical CO2 extraction, the line diagram, where all the carbon dioxide gas cylinders are coal heat exchanger, okay, extraction vessels, CO2, other chillers are there, okay, the extraction vessels are there. Here you can see here in the green part, that number 7, where you are putting the sample, whatever the sample that you want to extract the oil. Okay, here the CO2 will be mixing here. Once that CO2 is mixed here at a low critical temperature, it will extract, and here the oil will be separated, and with the help of this valve, so we are getting the oil. So this is a brief, small working principle of this supercritical CO2 extraction technology. And this is the actual photograph of this line diagram. So whatever the line diagrams are there, this is the actual photograph of the, you can see that the supercritical CO2 extraction method, which Thar company, now the water company has already taken over this Thar. So they are So again, this is one of the supercritical CO2 extraction. Another, you can say that still some people they are doing research on extraction of the oil or extraction of other compound from the any type of seed or any type of food material.
Dr. Pradhan,
Yes, sir. Yes, sir.
I have to do because we are. Can we move quickly to the conclusion because will be running short of time for discussion.
Okay, okay, sir.
We
Okay,
might have
I'll
one
be
or two.
concluding. I'll be concluding.
Okay.
I'll be concluding. Okay, sir. Okay. So these are the tabletop type oil expel. This is most common. I maybe many of are very famous. These are the, you can use in your home. You can use in your home to whatever the oil seed that you are taking. You can use for around 17 to 18,000 rupees cost is there. You can purchase and you can use this machine with the cold press oil you can get. Okay. So likewise, some enzyme assisted oil extractions are there where various type of enzymes are there, like ultrasound assisted extraction may be there where we are using the ultrasound technology to and this ultrasound technology is given as a pre-treatment to increase the oiling. Okay. So I told, so these are only the pre-treatment method where this microwave heating also given. In case of general heating that I told, where giving heat treatment, you can also give the heat treatment using the microwave so that quick heating can be done. This can also increase the oiling. Various research already done. So like a pulse electric field assisted, this is also a new field where we can give electric field, high electric field. Due to this high electric field, so there will be disrupt the cell wall. Because of that, the oil globule will be burst and that is a easy oil separation. So this is because of time schedule. I'm skipping up all these things. So okay, if someone is working on this all type of you can say technology or oil seed processing, so they can use all this recent advances technology. Okay, so they can do a good research paper, or they can do a good research, or in the same time, so they can get a high oil yield with a good oil quality. So this is what my lecture for today. So thank you. I'm concluding here, and thank you for listening to me. And if any questions, you can ask me now, or you can ask me later on through my email ID. My phone number is given, or you can contact to the organizer. If any type of help I can do, or any type of question I can give you answer. Thank you. Thank you so much, sir. I finished.
Thank you, Dr. Pradhan. Now the session is open for discussion. Everyone has been provided the necessary